time ago, there was an old woman and an old man. They were very happy in their life on the farm, but there was something missing, and that was a child. How they longed for a child, but they were never so blessed. Well, one day, while the man was out tilling the fields, the old woman was in the kitchen baking cookies, and she chose that day to make gingerbread cookies. And as she was rolling out the dough, she was thinking about how her heart longed for a child, and a single tear fell off her cheek and into the dough. So she cut the gingerbread cookies and she put them in the oven, and soon, the whole farm smelled like delicious gingerbread. But then, as she was taking the cookies out of the oven, one of the cookies popped off the tray and started running around the kitchen. And the old woman said, "Oh my goodness, you're alive! You'll be my very own gingerbread boy!" But that gingerbread man, he ran so fast. He went past the old woman and out of the door, and the old woman said, "Help! Help! Someone! Help me catch that gingerbread boy!" So soon enough came her husband, the old man, and she said, "Please, husband, get the gingerbread boy. He's going to be our very own boy." So the old man ran and he ran and he ran after this gingerbread man, and the gingerbread man said, "Run, run as fast as you can. You can't catch me. I'm the gingerbread man." And sure enough, try as he might, the old man couldn't do it. He ran out of breath and he had to call for help, help. So sure enough, somebody came to his aid. Who do you think it was? Well, it was the cat. And the cat said, "Meow, meow, I'm here to help." And the cat chased that gingerbread man, and he ran, and he ran. And the gingerbread man looked behind him and said, "Run, run as fast as you can. You can't catch me. I'm the gingerbread man. I ran from the woman. I ran from the man. I'll run from you too. See if I can." And with glee, that gingerbread man left that cat in the dust. And he just kept running and running and running. And finally the cat had to call for help, help. And sure enough, help came in the form of, what do you think? The dog. And the dog said, "Roof, roof, how can I help?" And sure enough, the dog started to chase that gingerbread man. And they ran and they ran and they ran and they ran, but that dog could not catch that scrappy little gingerbread man who yelled, "Run, run as fast as you can. You can't catch me. I'm the gingerbread man. I ran from the woman. I ran from the man. I'll run from you too. See if I can." And sure enough, that gingerbread man ran so fast and so far and so wide, the dog finally gave up, and was forced to call for help, help. And help did arrive in the form of, who do you think? It was the pig. And the pig said, "Oink, oink, how can I help?" And the pig started chasing that gingerbread man, and they ran 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 so far and they ran so wide and they ran so fast, but still that pig could not catch that gingerbread man. And the gingerbread man yelled, "Run, run as fast as you can. You can't catch me. I'm the gingerbread man. I ran from the woman. I ran from the man. I'll run from you too. See if I can." But finally the pig was forced to call for help, help. But no help arrived. And the gingerbread man kept running and 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 running till he stopped, because he came to a great big river, and that river was very long, and that river was very high, and he couldn't go around it, and he couldn't get across it, and he couldn't go through it because he was made of gingerbread man and would just gingerbread, and he would just fall apart. But then suddenly he heard a voice saying,
"I can help you, gingerbread man."
It was the fox. But should he trust the fox, thought the gingerbread man. Finally he looked at that fox and he thought, I have no choice. "Okay, fox, you can swim me across." And the fox said,
"All right, gingerbread man, hop on my back."
So the gingerbread man hopped on the fox's back, and the fox started swimming across the river. But the water started to come up, and it reached the gingerbread man's feet and started to creep up to his middle. And the fox noticed this and said,
"Come up to the top of my head, gingerbread man."
So the gingerbread man went up to the fox's head, and this worked for a while, and they were almost over halfway across the river. The gingerbread man could see the other bank in sight, but the water was creeping up again. Oh no, what to do? But the fox had an idea.
"Come up onto my snout, gingerbread man."
So the gingerbread man went for it. He went up to that fox's snout, but no sooner did he make himself comfortable when the fox opened his great jaws and... oh! And that, my friends, was the end of the gingerbread man. And the moral of this story is, no matter how fast you run, always be wary of foxes. The end.
Hi, boys and girls. Welcome to Fab Lab Week 3. I have a special guest with me today. This is my friend Bones. Say hi, Bones.
Hi, kids. How you doing today? Hey, would you like to hear a joke?
Go ahead, Bones. I'd love to hear it.
Who was the most famous skeleton detective? Give up? Sherlock Holmes! All right, try this one. What's the skeleton's favorite musical instrument? The trombone! All right, one more, Miss Erin, one more. What do you call a skeleton who won't work? Lazy bone! Waka, waka, waka. So, Miss Erin, what are we doing here today?
All right, Bones. So today we're going to look at different body parts, and we're going to try to find spots for them on your body.
Oh, body parts? Well, that sounds interesting. What are we starting with?
We're starting with your brain.
Brain. Oh, I don't know, Miss Erin. That looks kind of gross. What does the brain do?
So actually, the brain is a really important part of your body. It is like a computer that controls your entire body. And it has also a nervous system that sends messages throughout your body to the different parts of your body.
So wait a minute. It's the brain that makes your whole body work, and it's what we use to feel things and smell things and taste things?
Yeah, it controls all the functions of your body. And it also has different things for memory in there too.
Well, that brain sounds like a really important body part. Where does it live?
I don't know, Bones. Where do you think it lives? Maybe in your chest?
I don't think so, Miss Erin. That seems like a strange place for the brain.
You're right, Bones. Your brain actually lives in your skull up here. And your skull acts as something to protect the brain. So that way your brain, because you can see in the picture, it kind of looks really squishy. That way nothing hurts your brain, because your brain is actually really sensitive.
Well, I guess that's why my head's so hard. That makes sense. So, Miss Erin, can I ask you a very serious question?
Sure.
What did the doctor say to the man who had an elephant sitting on his brain?
I don't know.
Looks like you got a lot on your mind. Waka, waka, waka.
Oh, Bones, that wasn't a serious question. That was a really funny joke. So your brain, what I have in this picture, is actually what it would look like on the side of your head. But really, your brain would kind of go up here. So I'm just going to go ahead and put your brain up here. There we go.
Oh, this is going to keep the rain off. I love it, Miss Erin. Thank you. You know, I really wish we could do some sort of an experiment to help me understand exactly how the brain works. Do you have one?
I do, Bones. You really read my mind. All right, stay tuned, and we're going to do a little experiment for you about what the heart does.
Awesome.
As Bones requested, me and Miss Kate are here to demonstrate how the brain works. So what you need is a ruler, and a 12-inch ruler, and a partner for this. You can do this at home easily. So she's holding our ruler. And what I'm going to do is she's going to randomly drop it up. So now I'll show you my finger landed right at the 4.5 mark. And you can train yourself to react faster and faster. So the lower it gets, the better it is, because that means your reaction time is much better.
So how is this working exactly? What's happening is when I'm dropping the ruler, gravity is having it fall. And as it's falling, Miss Erin's eye is seeing it and sending messages up to her brain. And then the brain will translate those messages and send them down into her muscles and into her fingers. So the nerves of her fingers will immediately react and try to grab it. She may miss, but at least she'll know to try to grab it. And after the first time we do this, if we keep repeating this experiment, she's going to get faster and faster and better because her brain will know to expect it coming. So we can train our brain to do all kinds of things. But we have to train it. We have to get out there and try different things. So get a ruler, get a partner, and try this at home.
Well, Miss Erin, the brain sure is interesting. Do you have another body part to show us?
I do, Bones. I have the lungs.
The lungs. What in the world do they do?
Your lungs make you breathe.
Oh, breathing's important. That's what keeps us alive.
It is really important. What they really do is they bring oxygen, which is the healthy air that we breathe, into our bodies, called inhalation. So that's why when you hear the word inhale, it means breathing in because you're bringing the oxygen into your body, and it sends a chemical called carbon dioxide out, which is what happens when you exhale. So you get all the carbon dioxide out of your body and you get all the good air into your body. This exchange is called respiration. So that's really the most important function of our lungs.
Oh, where do the lungs live?
The lungs live in that place that I said your brain lives, in your chest, right up here.
Oh, that fits perfectly right there, doesn't it?
It does.
I guess that's why my bones are developed this way, to keep the lungs safe.
You got it, Bones.
You know, this is reminding me of a story. Did you know, Miss Erin, I recently had to get surgery done on my lungs.
You did?
Yes, the doctor said it was breathtaking. Waka, 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 waka. You know, Miss Erin, I'd like to learn more about how the lungs work. Do you have a science experiment to show us about it?
I do, Bones. Again, you read my mind. We'll go ahead and do that one right now.
Hello, boys and girls. So now we're talking about the lungs. And the lungs are really important to us because that's how we get our breath. And I don't know if you ever do any yoga, but yoga is so important to help us center ourselves and to feel more peaceful and to get rid of anxiety. And the basis of yoga is taking these big cleansing breaths, and that's just so important. But our breaths can also be powerful. They can work like tools almost. And Miss Erin's going to demonstrate how she can take her breath and keep a feather in the air. So this is something you can do at home. If you have any feathers, yeah, she's going to make her lungs work for her by keeping this feather in the air. Go ahead, Miss Erin.
So I'm just going to take a deep breath in, and when I let it out, try to keep it in the air for as long as I can. So take a deep breath in and let it out. Oh. Let's try this again. Take a deep breath in and let it out.
Whoa, look at her go. So just like with breathing and mindfulness, like it takes practice. But this is the only way you'll get good at it is by practicing. So take a feather and see how you do by keeping it in the air. Don't have a feather? Try with a cotton ball. There's lots you can use, but it will help you with your breathing and developing your lungs. Now, there's a game you can play. This is also a partner game, and we call it lung hockey. And for lung hockey, you need a ping-pong ball, you need a table, and you need 2 straws for yourself, one for you, one for your partner. And you're going to try to get this ball to go off the table on your partner's side so you can score a goal. So here we go. We're going to get our straws and our balls and blow. Oh, here it comes. Oh, that would be a goal for me because I have awesome lungs and I'm quite a hockey player, so I don't want to be trash talking Miss Erin, but yeah, I scored the goal. So kids, try that. Try lung hockey. But whatever you do this summer in your travels, please remember to use those lungs and to do some deep.
Well, those lungs sure are breathtaking. What else do you got for us, Miss Erin?
What I have for you is the heart, and you'll notice that this doesn't look like a heart shape we use for pretty pictures and designs to show love. This is a completely different kind of look.
Are you sure it's a heart?
I'm positive, Bones. It's the heart that we all have.
Well, what does it do? How does it work?
Your heart is really important. It sends the blood around your body. The blood provides your body with remember that good air, oxygen, and it sends out all the waste, all the bad kind of stuff in your blood. It acts as a pump, or two pumps in one. So it brings the good blood in and it pushes the bad blood out. It circulates all the blood.
Well, that does sound very important. Where does the heart live?
The heart lives in a spot right behind your lungs. So in this kind of little space, it kind of lives behind there. I'm just going to put it over so you can see. But really it would be a little smaller and kind of live right behind those lungs.
Oh, so it's tucked right in there, nice and safe.
It is.
Hey, Miss Erin, do you know what happened to the patient who refused to get a much-needed transplant?
I don't know what happened to that patient.
He had a change of heart. Waka, 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 waka.
Oh, Bones, you crack me up. You get my blood going.
Do you know a science experiment that could teach us a little more about the heart?
I do. I even have a model of how the heart works.
I can't wait to see it.
All right, well, stay tuned. All right, boys and girls, we're back with another experiment to show you ways that our heart works. What I have here to start with is a model of the heart that we made and a diagram of the heart. So here is the diagram of the heart, and as you can see, it's very, very complicated. We have many different valves of the heart, different components that are really important and help pump out the blood. Like our left ventricle and our right ventricles kind of act as those pumps, and one filters that out and one filters it inside. So that's what our heart looks like inside of our bodies. It really does some complicated, very important stuff. And now I have our model. So what I created, this is a model of the two valves of our heart. What happens is this one is acting as our pump. So when I push down on the middle, you'll see that water pours out of both straws, except the water in this straw where the pump is won't go back down because of the pump. You can easily make one of these at home. The directions will be in the show notes on how to do this, so you can kind of show your grown-ups or show anyone else the cool way your heart works. Very, very cool. All right, we are also going to show you a different way the heart works by working with our heart rates. Now, Miss Kate is going to help us with this one.
Now, what are we going to do, Miss Erin?
So what you're going to do is measure your resting heart rate.
Okay. So to find our resting heart rate, we had to do something called taking our pulse. And to take your pulse, hold up your right hand, and I want you to touch your left earlobe. And what you're going to do is you're going to move, you take first two fingers on your earlobe and move them down halfway around your neck until you can feel a little bump. You can feel your heartbeat. So Miss Erin's going to time, and I'm going to count how many beats I get within 15 seconds. So tell me when, Miss Erin.
All right, and also just make sure you don't use your thumb as one of your fingers, because your thumb has its own little heartbeat inside of it, so it won't work. All right, let me go ahead, and you can go ahead, I'll count.
Okay. Now?
Mm-hmm. Stop.
12.
12. So multiply that by 4. That's 48. So your resting heart rate is 48.
Okay. And now I have to get an active heart rate. And you know what that means, kids? Jumping jacks. All right, here I go. And jumping jacks are really great for getting your blood flowing and your heart pumping. And sometimes if I start to get sleepy, I just stand up right in the library and start doing jumping jacks.
That's definitely a good way to keep you up.
And if I'm studying and I can't get an answer, sometimes if you get up and do a few jumping jacks, you'll think of the answer. All right, now let's see what my heart rate is since I've done these jumping jacks. Okay, tell me when.
Go ahead. Go.
22.
22 by 4 is 88.
88.
So she jumped
Whew.
from 48 to 88 after doing about a minute and a half worth of jumping jacks. So the longer you exercise for, the higher your heart rate is going to go. Stop it there and then continue.
Yeah.
So what does that tell us exactly? So what that tells you is that when you exercise, your muscles use a lot of energy, which means your heart has to work even harder and pump even faster in order to get all the nutrients your body needs into your bloodstream to help energize your body as you're moving.
Okay, so just remember, kids, the harder you run, the harder your heart is pumping.
Well, we're learning a lot about the heart and the lungs and the brain. I wonder if you have anything else to teach us, Miss Erin.
I do, Bones. I have the knee.
Oh, the knee. I have one of those.
You
So,
do.
what does the knee do? What's interesting about it?
So the knee is the biggest joint in the human body, and a joint is a place where the bones meet. It's the biggest one in all of your body. I'll show you on your body in just a second, Bones. The knee is really important because it lets your legs straighten and bend. It also supports the weight of all the body above it. Our knee goes right here. Do you see that, Bones? Do you feel it?
I do feel it, Miss Erin. That's so interesting. How come the knee can it bend the other way?
It can bend the other way, too.
But it doesn't go all the way up. It just goes all the way back.
You're right, because the joint kind of keeps it in that one spot on the bottom. And remember, it also helps support all the weight above your knee. So all of this weight is supported by that one joint.
Knees are so important. We couldn't walk without them, right?
No, we couldn't, Bones. We wouldn't be able to move our legs as well. So I'm going to go ahead and put your knee on.
Can I ask a question about the knee, Miss Erin?
Sure, Bones.
What would you call your knee if it engages in a rap battle?
In a rap battle, I don't know what I'd call my knee.
This knee!
Oh!
Waka, waka, waka.
Like Disney? Like the movies? The company?
Yeah, but get it? This knee, like
Right.
this again.
That's funny, Bones.
Thank you. Do you have any experiment that could show us exactly how this knee operates?
I do. We're going to go ahead and do that right now.
Hello, everyone. We are back, and we are talking about knees. And you think, well, gee, how important really are knees? Well, we're about to see. Miss Erin, can you please just demonstrate walking normally?
Normally.
Now, can you please show us what it would be to walk if you did not have knees? So it's not impossible. It's just a little awkward, right? She can still kind of get around. Let's try running, because we saw with the heart how important it is to run. Can you run normally, please? Oh, look at her go. Okay, Miss Erin, what does it look like to run without knees? And how does that feel?
It feels really weird.
Do you think you could do that for 5 miles?
No?
No, I think it would be pretty impossible. So that wasn't terrible, but you know where knees really show us how important they are? It's in jumping. They really give us excellent range of movement. Okay, Miss Erin, can you please, and this is an experiment you can do at home too, put some water on your hand, and I want you to get down low, crouch down low, and jump as high as you can and show us where the water lands. Whoa, okay. Now, Miss Erin, can you get more water? And I'd like you to jump without using your knees. Okay, so how much of a difference is it between the first water mark and the second?
So this is where I jumped without knees,
Mhm.
and up here is where I jumped with my knees.
So can you imagine playing basketball without knees? We really need the knees for movement, especially for jumping. It's what helps our body to really perform. So try this experiment on your own. It just requires a wall and water.
Well, I'm starting to really feel like an expert about the human body, Miss Erin. Anything else to show us?
I have one last thing to show you for today, and those are your feet.
Oh, feet. I have 2 of those feet. Well, what in the world is important about feet? They're all the way in the bottom.
They are, but they're super important. They really help support your body. They touch the ground wherever you're standing, walking, or running, and they're extensions of your legs. So really, they just help move you around. After all, they're the foundation or the base of your body.
So what would happen if we didn't have feet?
You really wouldn't be able to walk as well.
Huh. Hey, can I ask another question?
Sure.
Why couldn't the 2 feet get along?
I don't know, Bones. Why couldn't they?
Because they both thought they were right. Waka waka waka. Got you again.
Brings me to a good point, Bones. You have one right foot and one left foot because they help balance your body. If you had 2 right feet, your body wouldn't be balanced and able to move as well.
Could you show us more about that, Miss Erin?
Definitely, Bones. I'm right on it. Thanks for joining us for another one. And in this one, we're going to show you how your feet are really important in maintaining your balance. Miss Kate is going to come up. You can do this at home. I'm sorry. We just have a broomstick and a plank we found. You put the plank on the broomstick. She steps on it, and you'll see that right now she's trying to find her balance. I'm going to ask her to try to move it so that the plank doesn't touch either side.
Oh, oops, I'm doing it.
There we go.
I do it, Miss Erin, but then I can't keep it for long. How in the world can I get better at this?
You have to keep practicing and train the muscles in your feet and your brain to help you stay balanced. See, the more she concentrates and uses her brain, the more she's able to keep balanced. Something in your brain that actually helps send messages to keep you balanced and works with the different muscles in the feet in your body to help you do that.
Now, what can I do if I get really good at balancing? How is that
You
useful?
can do stuff like snowboarding or surfing, different things that require you to maintain your balance. Or even in yoga too. We talked about yoga earlier. In yoga, it helps you practice your balance also.
So kids, just get a broom and get a plank and try it at home.
See how long.
Now we're going to move from feet and talk a little bit about shoes. Why do we wear shoes? Well, we wear shoes because, first of all, protection, so we don't hurt our feet, but also it helps us in our performance. Certain shoes will help us move with a little bit more control. Now, it's summertime and people enjoy wearing sandals. And sandals are great because they help our feet to breathe. They don't make our feet hot in the summer. But do we have control with the sandals? Miss Erin has a sandal that has a clip attached to it with a rubber band. And we're going to see how fast she can make that sandal move. So go ahead, Miss Erin. Whoa, what, that went really fast. Do it again. Okay, great. So it's definitely moving fast. The problem is that she doesn't have a lot of control with it, and she doesn't have a lot of protection with it. So it's not really great for running, but they kind of work that she won't step on anything sharp. That's what's nice about sandals, and they keep the dirt from the bottom of our feet. But really, they're not the best to run in because we'll be sliding all over the place. Let's try now with a fancy dress shoe. Oh boy, that does look sharp. And the whole foot is covered. So now she has her clip with the rubber band attached to it. Let's see how that moves, Miss Erin. Well, that's a heavier shoe. All right, now she has it on. So, okay, look, it's going a little slower, but she's still kind of moving around. So dress shoes, can you show us the bottom of those dress shoes, Miss Erin? So that has a little bit more of a bottom to it. The sandals were completely smooth, and that's why they were sliding all over. The dress shoe had a little bit more of a bottom, but it still kind of slides around. Dress shoes are actually great for dancing because you do have that movement, but it really doesn't have a lot of control for running. And that's why now we're going to look at a sneaker. Okay, now, Miss Erin, give it a try. Oh, so now it's even harder to move. Now, Miss Erin, can you show us the bottom of those shoes, please? So you see in the bottom she has rubber, and there's different imprints on rubber and on the rubber, and it's showing you the bottom of that shoe. It's creating friction with the floor, and friction is keeping it from going crazy and moving super fast. It's slowing it down and giving her control. So that's why we run in sneakers and not sandals and not dress shoes. Shoes are designed for lots of different purposes, but sneakers are the best for running. So I want all of you to throw on your sneakers and go run around and work out those lungs and get that heart nice and strong. All right, hello everyone. Now, what would a program about the human body be without showing a real competition. We are now going to have a race, not a foot race, not a horse race, but a color race. And if you can look over here, can you please point out our crayons, Miss Erin? You can see we have several colors of crayons. I wonder if we melt these crayons, which crayon will melt the fastest? So I want everyone to make a prediction. Look at those colors. Miss Erin, can you say the colors out loud for us, please?
This is purple, green, red, and blue.
Which one will melt the fastest and which will melt the slowest? Everybody make a prediction. Okay. Miss Erin, can you please get our heat source? Our heat source is this hair dryer. And please start the color run. So she's taking the hair dryer, and she's putting it in the highest setting possible. And she's going to work on melting these crayons. Now you can do this at home, and I'll tell you what we did. We just got a board, and we glued the crayons onto the board with hot glue. And underneath it, we have newspaper. And the newspaper is there in case it goes off of the board. But sometimes kids do this with just a bunch of crayons really close together of all different colors, and they melt it, and it becomes a piece of art. So this is also an art project that you can create. So here we go. Okay, folks, we are back, and here is the results of our color run. Miss Erin has been very evenly hitting all these crayons, and as you can see, it looks like the winner of the color run is purple, followed by blue, and then the green, and last but not least, red. So why did purple win? Well, the reason is that purple is the darkest color, and crayons with the darkest pigment will melt quicker than crayons with lighter pigment. And if you put a black crayon and a pink crayon right next to each other and blow with the heat at the same time, that black is going to go much quicker than the pink. And that's because darker colors attract and keep the heat. And if you don't believe me, go outside in a black t-shirt on a really hot and sunny day, and you will be so heated up so quickly. But if you go out in a white t-shirt, you'll stay much cooler. And that's why in cultures where they have a very hot climate, folks tend to wear a lot of white flowy clothing because it keeps the wearer cooler. So you want to stay nice and cool? Wear light colors. Now, at the very least, we have created a really cool work of art. So go ahead, glue some crayons to a canvas and apply some heat and see what you can create. Something scientific and something beautiful. The color run.
Thank you, Miss Erin. That was also interesting. I feel like I now learned so much about this great thing we call the human body. Tell me, how can I learn more about the human body?
That's a great question, Bones. You can learn more by reading books. We have here at the library, we have a lot of books about the human body and the way our bodies work.
Wow, I can't wait to crack into them. Can I ask you one more question?
Sure, go for it.
How did the skeleton know it was gonna rain?
I don't know. What do you think, boys and girls?
He could feel it in his bones. Waka, 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 waka. Gotcha.
A good one.
All right. Well, I think that's gonna wrap it up for today, everyone.
You're right, Bones.
Thank you for joining us.
Thank you for joining us, boys and girls. We'll see you back here next week. Say bye.
Bye.